Hello everyone, welcome to a new Cube video. I am your host Pavel Savyanko, main developer of Cube library, CubeGUI, Cube framework, and this video will be a little bit different than all others. So it will be not a video about the features of Cube, and neither it will be a video about some internals of Cube, but it would be rather, as I would call, about the ecosystem. So in this video I would demonstrate you how to instrument loops using Scorpy, how to enable disable clustering in Scorpy, to what it actually leads, and I will show you how this result is presented then in CubeGUI, and how does it change internals of the cube, especially syntax inside of cube profile.cubex file, because it is touching everything, basically the syntax, internals of cube profile, representation in CubeGUI, some plugins, and also the measurement. I call it as a video about the ecosystem because it connects pretty much various parts of the measurement, performance measurement. Another thing is I am, maybe you have noticed, I showed you how to use such plugin like heatmap, which displays performance of the loop over the iterations and the system tree as a heat map. And another plugin is bar plot, which I'm going to show in the next videos. So in this video, these plugins, they are working on loop measurements, iterations, and therefore I wanted to explain you and show you how one actually performs such loop measurement with Scorpy. So before we start, I remind you, please subscribe. If you have some questions, write them in comments, and press a like, of course, and advise us to another viewers or interested people in HPC. Okay, so let's go into the terminal. So let's go here, and here probably I would. So here is our terminal and source code of example of code which I just found in internet as example of using array data structure and going through it using loops like so here is the allocation of a vector full of integers of the size 100,000. So we initialize this vector with some data. It's basically from 0 to vector size times 2. Then we go over the first 1,000 elements and actually multiply it with random value from 0 to 10, and then in the end we print it out. So it's basically we have data structure and we run over this data structure using the loops. So let's take a look how we could actually measure it. So for that we go into actually directory where it is located. So I have already here some measurements. I remove them first. So to instrument, I have to have Scorpy in a path. Scorpy is available. I have also Cube available in the path as a GUI, and I have various tools available in the path. I am using Ubuntu. You can take a look in another video, actually a very short video in a channel, how to get your Cube as a standard installation on Ubuntu. Okay, that was just a side note. So anyway, we have this example of source code, and let's instrument it using Scorpy. For that we actually do following. I have here already actually examples. So here, that is the example of the code. So I am enabling instrumental wrapper flag user, because later on I am going to make user instrumentation. I am using wrapper Scorpy G++. We don't have MPI, we don't have OpenMP, just normal serial code. Loop naked. Naked means there is no manual instrumentation yet. And I produce just a dot, let's see, out code, and I want to have it verbose so that I can read what's going on. So here is the instrumentation, no errors, fine. If I take a look, I have a dot out, and to execute it, I have to here I specify how much memory I give for the Scorpy to do this measurement. Maybe that is totally overreaction, 206 megabyte for this measurement, but when I'm going to do loop instrumentation, I need a little bit more. So, and I execute it, and I see here the output from 0, 18, 8, that is this first 1000 elements of my array. And then if I take a look in a directory, I see that the measurement has been created, and I can take a look at this measurement, Scorpy profile, and I see that we have here the one visit of our application, one visit in main, 10,000 visit of this call get value, and the time is usual things, and we don't have any parallelity. We have only one process, so nothing special, but there are also no loops or whatsoever. Okay, how to make loops, how to instrument loops. For that we go to another source code which I have prepared, that is loop basic region. So we actually would like to have the measurement of every iteration of a loop. This is iterations of the loops are not calls, so therefore there is no compiler instrumentation possible, and we have to do manual instrumentation. How to do manual instrumentation? Please read guide from Scorpy. I will drop the link to it in description. So, but the main idea is one has to include header for macros, and then one defines actually the regions which we are going to use. I split the whole source code in two pieces, so region handle 1 and region handle 2, and starting from here to here, that would be my first region, which I call add, because we add up some values, and then we have another region, I call it print, here, because we're printing it out, and that's all. So basically that is the manual instrumentation. So what I want to see is that execution goes into main. Previously there was no another instrumentation, no resolution, but then it will add one call pass add. Under it there will be again 1000 get value, then it will leave this region and then go to another region, print, and there will be no sub elements because there is nothing, no calls are within this region, and then it will leave it. So that's what I expect to see. Let's take a look. For that we again perform instrumentation, but this time not naked, but basic region. We do B, for example. Okay, we have instrumented. We take a look, there is executable, and then if we execute it, we have second score P measurement, which we can inspect, and we see here that we have again the entrance into the application B out. We have the main, and then we have two our regions, print and add, and in add we have this 1000 executions of get value. If we take a look at info about this region, we see that this region is user defined. It is the source code lines. We can take a look at the source. So here is this region, here is this region. So it's perfectly fine, but we still cannot resolve the iterations of the loops. But we can already do manual instrumentation. All right, let's close it. Let's take a look how actually instrumentation of a loop looks like. So for that, we open another prepared source code. I call it loop 1. And there one can see that I add another region which I would like to resolve. And this region has a special type. It's dynamic and loop. Dynamic, it means this inside of the score P, it's handled as dynamic loop, which might appear or which might not appear, and so on. And it also marks it as a loop, so that possible optimization, clustering kicks in basically, or will be enabled or disabled. Another regions, as one can see, these are nothing else, just common type, so it means just normal region. So, and basically that is the most important part. That is how one marks the body of the loop. So here it is the loop which I would like to instrument. First 1000 iterations, not 100,000, but first 1000 iterations, there will be measured and moreover resolved. So it means I would see performance of every single iteration. Okay, let's take a look how it actually looks like. So for that we go again to instrumentation and we just choose here loop 1 and we do C. Okay, that's instrumentation. So we have another executable, C out, and we would like to instrument it, execute it, sorry. So for that I take a look at the history of my, here for example, this. So, and for this demonstration I disable clustering. Yeah, so I, by default, as soon as score P, as soon as score P detects loop, it enables clustering and starts to cluster the iterations. I disabled clustering explicitly, and let's take a look. 240, 550, 47. 7 profile, and what we see, 2004, so that's correct. And we take a look, print is again not resolved, it's only one region, but under add we see loop. So there are 2000 iterations, and if we open it, we see that we have from 1 to 1000 instances of the loop body basically, and under each of it there is a get value. And if we go on metric time, we see that the timings they differ slightly, and we can in this way resolve the execution of the loop. And we see that, for example, some of them timings are suddenly slightly larger than others. That might be caching issue, that might be some this random generator issue. One has to study deeply why this difference is, what causes this difference. But if one disables this clustering, one sees that the CubeGUI names every the loop body execution instance and then the number of this execution. Speaking a little bit ahead, if one goes and selects this body of the loop and sets it as a loop, one sees that the two additional plugins gets enabled, heatmap and barplot. Heatmap I already explained how it looks like. Barplot I am going to explain later on. And here one can hide iteration, and again we get basically the previous display of the loop iteration would be not instrumented and resolved, but for that we can study them using the bar plot, and one can show again iterations explicitly and then study each iteration separately. Okay, so that is how a result looks like if we disable clustering. So if we take a look with another tool, with CubeDump, for example, and we use so-called CubeDump W and very same profile, and then we enable pager, then we see that it starts normal, header, mirrors, matrix dimension, and here we see the list of regions, and there are this regions instance, and later on we have also individual call path with every instance. So why it is important? In a minute I will show you how the result will look like if one enables clustering. So for that we enable clustering here, true. So scorp profiling enable clustering. One can specify number of clusters. By default it's 64. Let's see, let's put 16 clusters. So internally the scorp will not measure every iteration, but it will try to cluster them together, and it will store only the clusters. So it will create 16 clusters, and if there are more different iterations than 60, so it will lead to compression, to reduction of data. If there are less iterations, then every cluster will be individual basically iteration, so there will be no improvement. But of course majority of loops go more than more than 16 iterations. Anyway, so let's do again very same executable, because we have instrumented loops. We just enable clustering or disable clustering. We execute it again, and then take a look. We have yet another. Now we have another scorp measurement. Let's take a look again. First with CubeGUI, and what we see again 2004 visits because we have additional loop. But if we open it, we see that it is already marked as a loop, because the clustering indicates for the CubeGUI that is the loop. And CubeGUI can immediately enable all technique for loop analysis. As we see, barplot and heatmap are available, because we study iterations of a loop. And then if we enable it, we see that the iterations are actually called iterations, and there are thousands of them, despite that we have only 16 clusters. If we take a look at the info here, what we see is, again, we see that it is user region, but this time the role is dynamic loop. And if we go in the global information, we see here that there is a cluster information is stored as attributes. So we see that for the iteration 1 it is 6th cluster, and that is also iteration 105 is 6th cluster, and 126, and so on and so on. So that is basically information which allows us to construct the loop, every iteration, out of clusters. Okay, and very same thing. One can hide iterations, and then the loop appears like it wouldn't be instrumented, but the plugins Bartlett and Heatmap are still available. Okay, let's take a look how it actually looks internally using the CubeDump tool. So for that we actually can use CubeDump -w and pager. And we see that Cube has global attributes which describe this clustering algorithm. I will explain the algorithm in details in another Cube internals video. Here I want to show how different parts of ecosystem again are connected. Scorpy enables clustering, disables clustering, GUI reconstructs the loop out of it, and there are changes in syntax of anchor.xml, and exactly this changes how it is constructed then in anchor.xml, and then algorithm of deconstruction I will then explain in a video about internals. So, and then if we list it, we see that there is a mapping for every iteration. So to which cluster does it map? Also the ID of root node, clustering is on perfectly. And then if we go down, we see that in a list of regions which are registered in a profile, we have actually exactly the 16 here. 16, from 1 to 16 instances, and these are clusters. So these are internal basically naming of cluster is instance. And then we have regions iterations which are created out of the clustering algorithm. There are 1,000 of them, and if one goes to call tree, one sees that here is iteration as an individual iteration, region name iteration. Fine. So if we take a look at CubeDump help, we see here one parameter -y. It disables expansion of clusters. In this way, it will show cube bare structure as it is stored in on a disk. It will not reconstruct the iterations of every loop. So let's take a look how it looks like. So we add -y, enter. We see that again the mapping, everything is clear, the attributes describing the mapping, but we see that here the only regions which are registered are actually cluster names and not iterations, because the cube didn't reconstruct the loop structure out of these clusters. And if one goes a little bit later, one sees that the loop has as a subtree instance, and so on, and that's all. So that is important for you later when I will explain how syntax of anchor.xml changes if one enables clustering. Okay, and the last demonstration which I would like to make in this video is actually parameter instrumentation. So every loop here is generated by Scorpy automatically. I marked it as a loop and dynamics, and they are named iteration 1 and 2. But actually for every iterations we have not only index, for example, changing, but also some another data structure, maybe some content of some array is changing, and we would like to see it actually in a profile. So for that, there is another example. I call it loop 2, where I actually define another region, and this region is resolving iteration of our loop print. So if we take a look here, we have a loop which goes from 0 to 1000, so it prints first 1000 elements, and here we go into again common region with handle 4, and then we see that by first 10 iterations we record parameter iteration, and its value is I, so it will be 0, 1, 2, 3, 4 till 9, and once it is bigger or equals than 10, there will be one parameter but always with the same value. So, and what Scorpy does, when it enters into the region and there is parameter and this value of parameter stays the same, it aggregates it together. If it changes, it creates another like call pass. So one can resolve execution or entrance to of the region by parameter. So one doesn't need to declare it being loop or dynamics. One can use the same word common, but uses the different value of the parameter. There are parameters integer, double, and string available. So take a look in a Scorpy guide how to make manual parameter-based instrumentation. So anyway, and then here we leave this region and we see that this region is inside of the loop body. So therefore we will have hopefully 10 first iterations separately and then the others aggregated. So let's take a look. So for that we instrument it again. So that is the execution. Here is instrumentation. So we go to 2 and create D. Enter. Okay. If we take a look, there is a executable D, and we can execute it. This time I will not disable enable clustering, it will be enabled by default. So and then let's go to D, enter. So execution is done, and then if we take a look, we have here additional Scorpy measurement, and we can inspect it using CubeGUI. And what we see is that this time we have 3000 visits, because we have instrumented first one loop with 1000 visits and then second loop with 1000 visits. So and then we expand, we have our add and we have print. So if we expand, we have here, we see here 2000 executions. Actually it is 1000 visits, but each visit there are two. For every iteration there are two visits, iteration itself and the call get value. That's why it is 2000. And here we have one visit of print, and then we see separately every loop, every instance of this region, and these are parameter, iteration 0, iteration 1. So I have resolved first 10 iterations, and the others are aggregated in this region. Because the first loop was marked as a loop, the bar plot and heatmap plugins are available automatically, but one can mark this loop as a loop. Then this marker loop jumps here. The previous loop is always then resolved, and here we can actually hide iterations and aggregate this loop, and then see display like was already presented, first 10 iterations, and then the value. Okay, How does it look like in profile? So let's close it here, or maybe no. Before that, I will show you how does it looks like in as a region. We see that the role is again regular user instrumented region user. But we have here parameter. This numeric parameter iteration is 1. Here is iteration 4. And for this, we have other iterations parameter -1. So and everything is here is aggregated. Okay. So and how does it look like using cube dump utility? Dump w. And we page it for comfort, of course, like this. Again, we see the clustering algorithm kicks in for the first loop, and for the first loop we have our instances, and then we have one region loop, that is our second loop basically. And then if we go down to the call tree, actually we see the clustered and reconstructed loop, first loop, and here we see our second loop. And this loop is not reconstructed by Cube library, it is recorded like this by Scorpy directly. For that we can again use the command line options -y. And let's go all the way down, and we see that this loop is resolved despite the declustering has been disabled. So these are the ways how one instruments and measures iterations of a loop, and by default clustering is enabled. By using the region type, loom, and dynamics, one tells the Scorpy that this is the loop body, and it starts to cluster it in order to save memory usage. And then later on it creates cube where it describes this clustering mappings, and then Cube library uses this information and recreates the complete loop with every individual iterations, and then one can see the results in a bar plot or in a heat map. One can disable clustering, then one can see the actually every iteration, but one would have larger memory footprint during the measurement. And in order to work with iterations and not with clusters, the Cube library performs this declustering, and this declustering I will explain in another video. So subscribe, put a notification, and wait for it. If you have any questions, put them in comment, and see you next time. Bye bye.